Well, hello and welcome to today's lesson. This first tutorial, we are going to continue to graph the sine and cosine functions. This time we will be including horizontal and vertical shifts. So we're in section 5.6 now, and what I've started here, this is our standard form for any of our functions. I happen to pick the sine function, but this easily could have been the secant function or the cosine function or the cosecant function, really any one of the 6 functions. The value of a, b, c, and d will always be in the same locations, and they will always do the same thing to each of our graphs. In a previous tutorial, we've already looked at what a does. You recall that a, now it's always the absolute value of a, it's always going to be a positive value for amplitude because this is the amplitude, it is the height. We call it the amplitude, sort of sounds like altitude. It affects the height, how tall our graph will be. And we've already looked at what B does. Now, B in and of itself is nothing, but B will affect the period. What we do is we take our normal period, which is, in this case, for sine and cosine, 2 pi. That's how long it takes before the graph repeats itself, and we divide by whatever B is. So B affects the period, and that's the accordion type thing. It will shrink horizontally or stretch horizontally. Okay, today we're going to be exploring C and D. Now C and B actually work together, and they represent our horizontal shift. The textbook will call it a phase shift when we're shifting horizontally. So C and B work together. If the value of C divided by B is a positive number, then we are shifting to the right. And if C over B is a negative number, then we're shifting to the left. But remember, C and B work together. A lot of times, B is going to be a 1, so it appears that it's C all by itself because it's C divided by 1, but it will always be C divided by B, so please watch out for that. And our final variable, I guess, is D, and this represents our vertical shift. And that's as simple as just looking at what D is. If D is a positive number, then we shift up. And if D is a negative number, then we shift down. So those are the 4 variables that will affect each of our graphs. So I have some examples to further clarify. Let's look at our first example. We have a sine function, and there are 4 parts that we're looking for, so we might as well just start listing them. I'm looking for amplitude. And amplitude is the value of A right here, and since that's a 1, I know that my amplitude is 1, and that's the normal amplitude. I'd also like to find period, and period, remember, is 2 pi normally, but we divide by whatever B is. And in this case, B is a 1, so 2 pi divided by 1 is still 2 pi. That's our normal period, and in parentheses, you don't necessarily need to do this, but it helps me. I like to mentally divide that equally into 4 parts, and 2 pi divided by 4 is pi over 2. That's what we normally count by, every 2 tick marks. I'll just put that in parentheses. The period is 2 pi. I'm going to say HS for horizontal shift, and the horizontal shift is C divided by B. The value of C, now watch out, remember standard form has a minus sign here, so this is standard right here. C is positive pi. So it's positive pi divided by what B is, and again, B is 1. So the phase shift is pi, which means since it's positive, we're shifting to the right. I'm going to put VS for vertical shift, and the vertical shift is what D is. I don't see a number out here, so it must be 0. So I'm just going to say that our vertical shift is 0. We're not shifting up or down. Now, what I like to do is I like to take my horizontal and vertical shifts together and realize that that's basically my new starting point. Since I'm going to be going pi units to the right and 0 units up or down, then that means that pi 0 is like my new starting point. So I need to go and start there because I really only want you to graph one period of each of these curves. Now, let's label our axes, and this is not one of the exceptions. 1, 2, 3, 4 units over will then be pi. 1, 2, 3, 4 more units would be our 2 pi. I like to go to the second tick mark to make my 1, and my second tick mark down here to make my negative 1. So our starting point is actually pi units from where it normally would be. I go pi units over. I like to put a little box. I don't put a dot necessarily because it's not necessarily a point that's on my curve. I like to put a little dot or a star or some sort of indication that this is where I've shifted to. And now all I need to do is do my pattern. I do need to remember that this is a sine curve, and the sine curve looks like an S, so I know that actually I do start right here at 0, 0. This is like my new origin. When I go pi over 2 units, that's 2 tick marks, I get to go up to my 1. And then when I go 2 more tick marks, I'm back to 0. And when I go 2 more tick marks, I'm down 1. And when I go 2 more tick marks, I'm back to 0. And this is the first period of this sine curve. And that's really all I want you to graph. You can see that, of course, we've shifted pi units to the right. Everything else stayed exactly the same. If we look at our second example is a cosine. Let's find all of our pieces first. Let's start with amplitude. Our amplitude is still a 1 since it's a 1 is the value of a. I'm looking for my period, and my period is going to be 2 pi divided by whatever b is, and again, b is a 1. So that's still 2 pi, which means it's still my normal count. Every 2 tick marks, or pi over 2 units, I'm going to be getting a new key point. My horizontal shift, I'm looking for C and I'm looking for B. This time the value of C is negative because we must have been subtracting a negative to make this positive. That's why C is a negative pi over 4. And I'm going to divide that by B. B again is still a 1, so now my shift horizontally is negative pi over 4. That means I'm going to be shifting to the left. And finally, my vertical shift, it doesn't have one here as well because D is 0. So again, I like to use those 2 points to realize that that's where my new starting point is, negative pi over 4, 0. Now I just need to plot that. I can't really plot that until I have my axes. Looking at my period, it's the normal period, so this is not an exception to the scales. So 1, 2, 3, 4 tick marks over is pi. 1, 2, 3, 4, 8 is 2 pi. I know that there's a shift to the left, so in this case, I'm going to go 1, 2, 3, 4 units to the left and put negative pi. I know that you don't need to put all of these, but it helps me so I don't miscount. And I'm going to go to the second tick mark and make that a 1. And the second tick mark and make that a negative 1. Remember, I'm going to give you some leeway on the y-axis. I try to be as consistent as I can, though. So let me start where my new starting point is. I know I'm going negative pi over 4 to the left, and then I'm stopping. I'm not going up or down. So if I go to the left, 1 tick mark, that represents negative pi over 4. So my graph's going to start there. I'm not going to put a dot. I'm going to put a box. That just represents my new starting point. And now I need to understand that my pattern is going to be the cosine pattern. And that's the one that looks like a C. So I know that actually this is not a point. It would be if it were a sine. The point for cosine starts 1 unit above my starting point. And then I start counting 2 tick marks over to a 0, 2 tick marks over to a negative 1, 2 tick marks over to a 0, 2 tick marks over to the positive 1. And that is the first period for this cosine curve. Make sure that it's a curve. Don't connect the dots in straight lines. It looks like we're just shy of where we normally would be ending at 2 pi, but we're exactly 1 tick mark shy of that because we shifted 1 unit to the left. Let's look over at example number 3. Okay, let's start spilling out our information. Let's look for amplitude, and amplitude again is 1 because C is a 1. Excuse me, because A is a 1. And period this time, normally our period is 2 pi, but this time we divide by b, and b finally is a different number. It's 2. So our period has changed, and it's gone from 2 pi to 1 pi, which means that what we normally count by has been cut in half as well. So I take my period and divide it equally into 4 installments, which in this case would be pi over 4. Again, you don't need to put what's in parentheses, but that just helps to remind me what I'm counting by. Again, our new key points, like we said in the previous tutorial, is our period divided by 4. And I put that in parentheses. Horizontal shift, we take the value of c, which in this case is positive pi, and we divide by what b is, and in this case b is something other than 1, so yay, we have a different horizontal shift, and that's pi over 2. That means that we're shifting to the right, and unfortunately we still do not have a vertical shift, that's 0. So together these 2 points, or excuse me, these two shifts make this my new starting point. Pi over 2 to the right, 0 up or down. So let's get our scales. This period does not change my scales. It's still 1, 2, 3, 4 tick marks to make pi. And I don't really need to go out there. Actually, maybe I do. 2 pi. I'm going to make the second tick mark 1 and the second tick mark down here -1. And now let's go to where my shift is. It was pi over 2 units to the right. So that's exactly 2 tick marks. I put a little box. Let's see what I'm going to be doing. Oh, it's a cosine curve. So that's the one that looks like a C. So it's a good thing I put a box because now I'm starting 1 unit above the box. Now normally we'd go 2 tick marks over to get to our next key point, but because our period was cut in half, our key point distance is cut in half. So I'm not going 2 tick marks, I'm going 1 tick mark to get to 0. One more tick mark to get to -1, one more tick mark to 0, one more tick mark to get to +1, and finish that. This is a cosine curve that has taken exactly 4 tick marks, or pi units, to start and stop. We don't get to go 2 pi units this time because our period is cut in half. Looks like a little reindeer. Okay. And example number 4. Let's find our amplitude. Boring, our amplitude is still 1. That's what we did last tutorial, which is why I'm not changing amplitude much in this tutorial. Our period, we need to figure out what b is, and b is just a 1 again, so it's just 2 pi divided by 1, which we all know is 2 pi. And again, that's just our normal counting, so we're just going to do pi over 2 units for every key point. Our horizontal shift, this time I don't see a value in the parentheses. In fact, I don't even see parentheses. If you want to put them in, there you go. Please do not think that this is in parentheses because I don't see parentheses. This must be the value of d, therefore c is 0. So if I take c and divide by b, I get 0. So no shift horizontally this time. My vertical shift, though, is what I see here. That's the value of d, and that's 2. That means that I'm shifting up. I'm going to take those two values and make them my starting point. 0 units left and right, 2 units up. So there's my new starting point. My period does not change my scales. 1, 2, 3, 4 is pi. 1, 2, 3, 4 more is 2 pi. I know that I normally go up 2 tick marks to get to the 1. That would mean that this is a 2. And actually, I know that I'm going to be going 1 unit above that to a 3. I'm not too afraid to go off the patch too much. This might be one of the examples that you change your scales on the y-axis and just count each tick mark, and I'm fine with that. As long as it's labeled, I'm giving you leeway, more leeway on the y-axis than the x-axis. So I'm fine with that, but I'm not too afraid to go off the patch a little bit. It's just a little bit off. Okay, our starting point is 0, 2. So that's right here. I'm going to put a little box. That's where my graph is going to start. Now let's see what pattern it's supposed to be. Oh, it's a C again. It's the cosine curve. So from my box, I go 1 unit above the box. And let's just check our stuff again. Yep, we're counting by pi over 2. So that means this is like my new x-axis. Understand that this horizontal line is where I'm traveling. This is like my 0, 0, my origin. So 1 unit above the box, count 2 over to get to my quote-unquote 0. Count 2 more, and then we're 1 unit below. Go back up. And then count 2 more, and we're at 0. And then count 2 more, and we're 1 unit above, which, yeah, I'm not too afraid to be up there. It's about right. And there's our cosine curve. that's been shifted 2 units up. Now, when we have a vertical shift, you might see that our range has changed. The domain, of course, is still all reals, but the range in this case has changed. This time, our lowest value of outputs is a 1 right here at the bottom of this valley. So my lowest value for the range is 1, and then I travel all the way up to this value, which is the highest, the part of the peak, and that is 3. So our range will change with our values of d, with our vertical shifts. And moving on to our final 2 examples, let's look at example 5. Let's start listing our stuff. Let's start with amplitude. Remember, amplitude is always the absolute value of this number. Since this is a -2, the amplitude is still 2. But I don't want to forget that there is a negative. That is going to do something to our graph. It's going to flip it upside down. So maybe in parentheses, just make note of a minus sign, or put a little star by it or circle it. Make sure you don't forget in the end that we're going to actually reverse our direction of opening. Okay, so the amplitude is 2 though, if I ask for amplitude, because it's always an absolute value. It's a height. It's twice as tall. It might be going upside down, but it's still twice as tall. Period. We take our normal period and we divide by b. Our normal period is 2 pi. B is still 1, so our normal period is still the same. And that means that our normal counting is every 2 tick marks, pi over 2. Okay. Horizontal shift, we're looking for a value of c. I don't see a value of c because, again, there's a 0 in here. I don't see a set of parentheses, so therefore horizontal shift is going to be 0. 0 divided by 1 if you really want to put. And vertical shift, that's the value of d. In this case, it's a -1. So I'm going to use my horizontal and vertical shifts to realize that that's where I'm traveling to start, 0, -1. And now let's make our scale so we can find that point. Normal scales, because our period is still normal. 1, 2, 3, 4. I should say not because it's normal, but because it's easy to find with our normal scales. If it's difficult to find, that's going to be one of the exceptions. 2 pi over there. And I'm going to go up to the second tick mark and make a 1, and the second tick mark down here and make a -1. And in fact, since I'm shifting down, I'm going to make one more tick mark just so I don't miscount. 0, -1 is where I'm starting. I put a box, maybe a star or heart or some cloud or some open circle, some indication as to where our new origin is. And now let's look at our graph. Oh, this time we got a sine. That's our S curve. And we need to remember that we're going twice as tall. And we need to remember that we're going in the opposite direction. So normally, actually I am starting here anyway because 0 multiplied by 2 doesn't change anything. But normally when I go 2 tick marks over, I'd be going up 1 tick mark. But because the amplitude is 2, I go up twice as much. But because it's negative, I don't go up at all, I go down. So I'm going down 1 and then down, oh, I need to get some more here. So I'm going to go here to -3. And now I'm in purple. So 2 tick marks over, and then I'm going down 1, 2 to get to my sine curve. So again, maybe this is one of the times that you would change your axes on the y. I'm not too afraid to go off just a little bit. Okay, so here's my 0. 2 tick marks over, I'm down 2, and then back here. And then 2 more tick marks, I'm at 0 again. 2 more tick marks, this time I go up. 1, 2. 2 more tick marks, and I'm at 0. And there's my S. Now it is in the opposite direction. And it's twice as tall. Make that a little bit bigger. Okay. Cool. Let's see what happened to our range in this case. Our domain is still the same. But let's see what happened to our range. How low do we go? The lowest point we have is now -3. And the highest point is right there, which is a 1. So it's good to practice the range. And finally, we've got our example 6. I tried to throw as much in here as possible. I didn't throw a D in there though. Oh well. So let's look for our amplitude. Amplitude this time is only 1/2. We're only going to be going half as much. Okay. And period We take our b, we take our normal period, 2 pi, and divide by b. 2 pi over 3. Ooh, that rings a bell. This is going to be one of the exceptions. If I take 2 pi over 3 and divide by 4, we've done that work before. I'll come and do it again. 2 pi over 3 divided by 4 is the same thing as multiplying by 1/4. So that's going to be 2 pi over 12, or rather pi over 6. That's what we're actually going to be counting by. And pi over 6 is a difficult value to see if we use 4 tick marks for pi. So this is going to be one of the exceptions. We can use 6 tick marks. Okay, let's do horizontal shift. That's the value of c, which is negative 2 pi, divided by b, which is 3. So that means we're shifting to the left. And like I said, there is no d, so vertical shift is 0. I use these two values together to say that we're going left 2 pi over 3, and then we're stopping. We're not going up or down. So again, this is one of our exceptions. Because our period of 2 pi over 3 is difficult to see if we're sectioning into quarters, into fourths, that's when I will let you change to 1, 2, 3, 4, 5, 6 tick marks before you put the pi. 12 tick marks before you put the 2 pi. I know there's a shift left, so I'm going to go 1, 2, 3, 4, 5, 6 tick marks this way and label a negative pi, just because I don't want to miscount. I'm definitely going to stick with my 2 tick marks up and 2 tick marks down for my 1 and my negative 1. It's going to be easier to see the 1/2. And let's see what we've got now. I'll just pick brown here. Where am I going? I'm going negative 2 pi over 3 to the left. Negative 2/3 of a pi. Well, if this is full pi, and it's 6 tick marks, then each 2 represent a third. So here's 1/3, here's 2/3, here's 3/3. So 2/3 to the left would be right there. Or I could count 1, 2, 3, 4 sixths, and 4 sixths reduces to 2/3. So there's my starting point. And I didn't go up or down. Okay, let's check other stuff. My amplitude is 1/2, so I'm only going to be going 1/2 as tall. And I'm counting every tick mark in this case, which is pi over 6. And it's a sine curve, so it's going to look like the S. Let's put all that together, starting here at the box. Sine curve fills in the box because we start at 0. We go 1 tick mark over, or pi over 6, so that we can go up 1. But we normally go up 1. Not this time. We only go up half as much. 1 more tick mark and we're at 0. 1 more tick mark and normally would be down 1, but this time it's only down half as much. And then 1 more tick mark and we stop at 0. We got to the origin. We didn't even get to go into the positive part of the x-axis. In fact, we shifted 2 pi over 3 to the left, and since our period was exactly 2 pi over 3, that filled the entire part. We could go ahead and do the range, because our range technically changes when A is changing from 1 as well, not just with vertical shifts. Now we're going from negative 1/2 to positive 1/2. So we can do that. I'm still using brackets because those points exist. The very lowest point and the very highest point, they exist. So hopefully you understand what's going on with our graphs of sines and cosines from all 6 of these examples. And we'll practice this more in class. Thanks for watching this tutorial.